Hello there, you are once again welcome to my channel. So today I will be showing you how to solve simultaneous linear equations with three unknowns. Okay, alright, but before we do that, please make sure you subscribe and then you share the videos. Okay, so we have 5x minus 3y minus 2z equals 31, which is equation 1, and then 2x plus 6y plus 3z equals 4 as equation 2, and then we have 4x plus 2y minus z equals 30 as equation 3. So let's start with the solution. Please make sure you subscribe. Okay, so we have 5x minus 3y minus 2z equals 31 being equation 1, and then 2x plus 6y plus 3z equals 4 being equation 2, and then we have 4x plus 2y minus z equals 30, which is equation 3. So we take a pair of equations and then eliminate one of the variables. Okay, so let's take equation 1 and then equation 2. So we have 5x minus 3y minus 2z equals 31, which is equation 1, and then 2x plus 6y plus 3z, which is equal to 4 as equation what? 2. So let's multiply equation 1 by 3 and equation 2 by 2, and when we do that we are going to get 15x minus 9y minus 6z equals 93, and then 4x plus 12y plus 6z equals 8. That is 3 multiplies 5x to be 15x, 3 multiplies 3y to be 9y, and then 3 multiplies 2z to be 6z, then 3 multiplies 31 to be 93, and then 2 multiplies 2x to be 4x, 2 multiplies 6y to be 12y, and then 2 multiplies 3z to be 6z, then 4 multiplies 2 to be what? 8. I hope you are following it. Okay, so we add 15x minus 9y minus 6z equals 93, and 4x plus 12y plus 6z equals 8. And when we do that, we are going to get 19x plus 3y equals 101. I hope you are following it. 15x plus 4x will give us 19x. Negative 9y plus 12y will give us 3y. Negative 6z plus 6z will be 0. That means z has been eliminated. And then 93 plus 8 will give us what? 101. I hope you are following it. Okay, so let's represent this equation as equation 4. So we take another pair of equation, that is equation 1 and equation 3. And equation 1 is 5x minus 3y minus 2z, which is equal to 31. And equation 3 is also 4x plus 2y minus z is equal to 30. I hope you are following it. Okay, so let's multiply equation 1 by 1, and then we multiply equation 3 by 2. And when we do that, we are going to get 5x minus 3y minus 2z equals 31, and then 8x plus 4y minus 2z equals 60. So we subtract 5x minus 3y minus 2z equals 31 from 8x plus 4y minus 2z equals 60. And when we do that, we are going to get 3x plus 7y equals 29. I hope you are following it. So we can represent this equation also as equation 5. So let's take equation 4 and then equation 5, and then we solve for x and y. So we have 19x plus 3y equals 101, which is equation 4, and then 3x plus 7y equals 29, which is equation 5. So we multiply equation 4 by 7, and then we multiply equation 5 by 3. So when we do that, we are going to get 133x plus 21y equals 707, and then 9x plus 21y equals 87. So we subtract 133x plus 21y equals 707 from 9x plus 21y equals 87. And when we do that, we are going to get 124x equals 620. Therefore, to solve for x, we divide 620 by 124, and that is going to give us 5. I hope you are following it. Okay, so let's substitute x into equation 4. So we have 19 multiplying 5 plus 3y equals 101. So 19 multiplies 5 to give us what? 95 plus 3y equals 101. So therefore 3y equals 6. And how did we get that? We subtracted 95 from 101. that is by means of grouping like terms. So when you subtract 101 minus 95, we are going to get 6. So therefore, y is going to be 6 divided by 3, which is going to be 2. I hope you are following the steps. We take any of the original equations, that is equation 1, 2 and 3. We take any of the original equations, then we substitute x, the value of x, and then the value of y, so that we can find z. I hope you are following it. So let's take equation 1, and equation 1 is 5x minus 3y minus 2z equals 31. So we are going to substitute x, the value of x and the value of y, into this equation. That is 5x minus 3y minus 2z equals 31. So we can find z. I hope you are following it. Okay, so we have 5 multiplying 5 minus 3 multiplying 2 minus 2z equals 31, because x is equal to what? 5. So 5x, that means 5 multiplies 5, and then y equals 2, and we have 3y, so 3 multiplies 2. Okay, all right. So when 5 multiplies 5, we are going to get 25, minus when 3 multiplies 2, we are going to get 6, minus 2z equals 31. So therefore, negative 2z is going to be 31 minus 19. I hope you are following the steps. So z is going to be negative 6. That is 31 minus 19 divided by negative 2, and that is going to give us negative 6. So our final solution is x is equal to 5, y is equal to 2, and z is equal to negative 6. Thank you so much for watching. Okay, so this is the example 2 of the simultaneous linear equation with 3 unknowns, and I want you to watch this video carefully. Okay, just take your time and then watch it carefully. I am going to show you how to solve simultaneous equation with 3 unknowns. Okay, I am going to show you step by step how to solve it. Okay, all right. So we have 3x plus 2y minus z equals 19 being equation 1. Then 4x minus y plus 2z equals 4, which is also equation 2. And then 2x plus 4y minus 5z equals 32 as equation 3. Okay, so let's move on. Solution. So we have 3x plus 2y minus z equals 19 as equation 1, and then 4x minus y plus 2z equals 4 as equation 2, and then 2x plus 4y minus 5z equals 32 as equation 3. Okay, so we take a pair of the equations and then eliminate one of the variables. Okay, so we are going to take equation 1 and then equation 2. Okay, so equation 1 is what? 3x plus 2y minus z equals 19. And then equation 2 is 4x minus y plus 2z equals 4. I hope you are following it. Okay, so let's multiply equation 1 by 2 and then equation 2 by 1. And when we do that, we are going to get 6x plus 4y minus 2z equals 38. And then 4x minus y plus 2z equals 4. So what we do next is we add 6x plus 4y minus 2z equals 38 and 4x minus y plus 2z equals 4. And when we do that, we are going to get 10x plus 3y equals 42. That is 6x plus 4x will give us 10x, 4y plus negative y will give us 3y, and then negative 2z plus 2z will be 0. So automatically z has been eliminated. Then 38 plus 4 will give us what? 42. So we can represent this equation as equation 4. I hope you are following the steps. Okay, so let's take another pair of the equation, and now we are going to take equation 1 and then equation 3. So we have 3x plus 2y minus z equals 19, which is equation 1, and 2x plus 4y minus 5z equals 32, which is equation 3. So we multiply equation 1 by 5, then we multiply equation 3 by 1, and we are going to get 15x plus 10y minus 5z equals 95, and then 2x plus 4y minus 5z equals 32. I hope you are following the steps. So we subtract 15x plus 10y minus 5z minus 95 from 2x plus 4y minus 5z equals 32. And when we do that, we are going to get 13x plus 6y equals 63. That is 15x minus 2x will give us 13x, and then 10y minus 4y will also give us what? 6y. Negative 5z minus negative 5z will be 0. So z has been eliminated. And then 95 minus 32 will also give us 63. So we can represent this equation also by equation 5. I hope you understand. So we take equation 4 and then we take equation 5. Then we solve for x and then y. Okay, so we have 10x plus 3y equals 42 as equation 4, and then 13x plus 6y equals 63 as equation 5. So let's multiply equation 4 by 2, and then we multiply equation 5 by 1. And when we do that, we are going to get 20x plus 6y equals 84, and then 13x plus 6y equals 63. Okay, so we subtract 20x plus 6y equals 84 from 13x plus 6y equals 63, and that is going to give us 7x equals 21. That is 20x minus 13x will give us 7x. 6y minus 6y will give us 0, so y is cancelled out. Then 84 minus 63 will also give us what? 21. So therefore x is going to be 21 divided by 7, which is going to be 3. I hope you are following it. Okay, so let's substitute x, that is the value of x, which is 3, into equation 4. And equation 4 is what? 10x plus 3y equals 42. So wherever we see x, we substitute 3 there. Okay, so we have 10 multiplies 3 plus 3y equals 42. So when you multiply 10 by 3, we are going to get 30 plus 3y equals 42. So therefore 3y equals 12. That is by means of grouping like terms. Okay, 42 minus 30 will give us what? 12. Okay, so we have 3y equals 12. So therefore y is going to be 12 divided by 3, which is 4. Okay, so now we take any of the original equations, and then we substitute the values of x and y so that we can find z. I hope you are following it. We take any of the original equations, then we substitute the value of x and y so we can find z. And we are going to take equation 2. Okay, and equation 2 is 4x minus y plus 2z equals 4. So let's substitute the values of x and y into the equation. So we have 4 multiplying 3 minus 4 plus 2z equals 4, which is 8 plus 2z equals 4. That is by means of grouping the like terms, because 4 multiplies 3 to be 12, and 4 subtracted from 12 will give us what? 8. Okay, plus 2z equals 4. So therefore 2z equals 4 minus 8. Therefore z is going to be negative 2. That is 4 minus 8 divided by 2. 4 minus 8 divided by 2. So z is going to be negative 2. So our solution is x is equal to 3, y is equal to 4, and z is equal to negative 2. I hope you followed the steps and you now understand and can solve simultaneous equations with 3 unknowns. Please make sure you subscribe to my channel and then share the videos. Thank you so much.